Welcome back. We continue with week 5. We're going to look at logic coverage criteria this week. In the last lecture, I introduced you all to logic, the basics of logic, told you about propositional logic, predicate logic, and what it's all about. This time, we're going to use logic to define coverage criteria and eventually, down the line, in the next few lectures, learn about how to do source code testing, specifically decisions in source code, by applying the logic coverage criteria that we are going to learn today. So, this is a recap from the last lecture. A predicate is any expression that returns true or false. That is, it evaluates to a Boolean value. So, here is an example. This predicates typically occur as labels of if statements, while statements, and so on. So x is greater than y. This v like symbol, read it as or, c, or f of z is a predicate, where x, y, and z are variables that are non-Boolean. Could be integers, could be real numbers, anything. C is a Boolean variable. It's used as a first class entity. And f is a function that returns a Boolean constant. That's why it's odd with the rest of it. This predicate has three clauses. A clause is a specific predicate which is free of logical operators like and, or, not, etc. So the clauses in this predicate are x greater than y, first clause, c as a standalone entity, second clause, f of z as the third clause. So these are the three clauses in the predicate. So please remember what a predicate is and what a clause is. In some sense, if I write an if statement or even otherwise, different programmers could write the same predicate in different ways. And as long as they are syntactically equivalent, they will mean the same. So we don't worry about whether the predicate is written in one way or the other. We just consider it as it is given to us and move on with working with criteria. We assume that a predicate will yield the same test requirement for a given coverage criteria, no matter what are the various syntactic ways of writing it. Small set of notations that will help us through these lectures. For any particular software artifact, let's say program, we'll collect a set of predicates. Let's call that set of predicates as capital P and collect all the clauses for all the predicates in C. That set will be called as capital C. So this set of predicates capital P, in that each predicate small p will have its own set of clauses. So we'll call it a C subscript P. CP is the set of all clauses that occur in the predicate. And the set of all clauses for the set of all predicates capital P is nothing but the union of the clauses in the individual predicates. We move on to looking at coverage criteria. So as I told you, our biggest use is predicates come as labels for if statements, while statements, switch statements, for statements, and so on. So simplest use of it is let the whole predicate return true once, let the whole predicate return false once. That is, test requirement is cover the predicate. For each predicate in the set P that you have collected from your software artifact, which could be code, test requirement or TR contains two requirements. The whole predicate evaluates to true, the predicate P evaluates to false. For example, if I had the same predicate that we looked a little earlier, x greater than y, or c or f of z, test requirement for predicate coverage would be let this entire predicate evaluate to true once, let this entire predicate evaluate to false once. So here are some assignments. Suppose x was 5, y was 3, c was assigned true, and f of z returned false. Then you substitute it back here, use the semantics of or, x greater than y, it is true, 5 is greater than 3, c itself is true. So true or with true is true, and f of z returns false, but the overall predicate will turn out to be true. And for the predicate to evaluate false, because it's an or, all three clauses should evaluate to false. So we assign values for x and y as sample values such that x is not greater than y. For example, x could be 1, y could be 4. The binary constant c will have to directly be false, and f of z again returns false. So x is not greater than y, C is false, f of z is false. So this predicate, which is an OR of the three clauses, will evaluate to false. So this is what is predicate coverage. Test requirement says for every predicate in the collection of predicates that you have, make the predicate true once and make the predicate false once. Assign values like this. So if you remember, what will this do? Suppose this was occurring as the label of an if statement. It will end up taking the true branch of the if statement once, and it will end up taking the false branch of the if statement once. So now you go back and compare it to the graph coverage criteria that we saw. This is nothing but edge coverage in the graph. Two different edges come out of a node because that node was probably an if statement, and one part evaluated to true, one part evaluated to false. Any kind of decision, it could have been a while statement or a for statement, and that's exactly what we are doing here. But our focus is not to view it as an edge, not to look at it as a control flow graph, but to consider the predicate that labels the statement and evaluate it to true once and evaluate it to false once. Is that clear? So this is exactly the same as edge coverage that we saw in the graph coverage criteria. Now let's look at it. If you see predicate coverage, you take this example that we just saw in this slide here. Consider how many clauses does this predicate have? Three clauses: x greater than y, c, then f of z. Right? Now if you see in this case, first part in the predicate coverage becoming true, first predicate evaluated to true, the first clause, sorry, evaluated to true, x greater than y. In the second requirement, first clause evaluated to false. Similarly, for this one, c evaluated to true, and in this one, c evaluated to false. Right. In the third clause, f of z, we happen to assign f of z as false in both the cases. That's what is written here. Individual clauses don't get exercised. By exercised, we mean they don't get evaluated to different truth and false values in predicate coverage. We can still achieve predicate coverage while an individual clause stays true or stays false. For example, in this predicate, in the previous slide that we saw, both the cases for predicate coverage, the clause f of z stayed as false. In testing, this may not be a desirable thing because there could be an error when the clause f of z is tested for being true. The source of the error could be there, and by not exercising each clause to become true once and become false once in turn, we might miss certain errors. So, to overcome this drawback, we introduce a new coverage criteria. We say consider covering every clause. So that is called clause coverage. So for each clause that you collect from all the predicates in your software artifact, your test requirement contains two. Per individual clause, C, let's say, let C evaluate to true and let C evaluate to false. For example, if you take the same predicate, x greater than y or c or f of z, which had three clauses, we take each of the three clauses and make it true once, make it false once. So x greater than y is made true once by, say, assigning x is 5, y is 3, is made false by assigning x is 5, y is 6. C is made true once, c is made false once. F of z is made true once, f of z is made false once. Right? So this is what is clause coverage. But now the reverse problem will happen. Just as we said, predicate coverage didn't exercise every clause, the reverse could also happen. Clause coverage need not make the predicate true once and false once. That is, it need not subsume predicate coverage. Here is an example. Suppose you consider the predicate without any specific instance. Let's say the predicate takes the form A or B. That is, it has two clauses, clause A and clause B. And I'm writing out the truth table for this predicate here. This table that you see here is what we call the truth table for the predicate. We've seen this in the last module also. It's basically the truth table for A or B. So assign true false values to A or B. Four different combinations exist. Both could be true. A is true, B is false. A is false, B is true, or both of them are false. Those are the four rows here and the first two columns. In the last column, you assign the truth or falsity of A or B. In the cases in the first three rows where at least one of A or B is true, all the three cases, the predicate A or B becomes true. In the last case, when both are false, A or B stays false. Suppose for my test requirement for clause coverage, there are two clauses here, A and B. So clause coverage can be met by considering row 2, which assigns A true once, B false, along with row 3, which makes A false and B true. So if you say A is made true ones and false ones between rows 2 and 3, B is made true ones and false ones between rows 3 and 2. In both the cases, we have achieved clause coverage, but what is the result of the predicate? If you see here, in both the cases, the predicate evaluates to true. So the predicate never becomes false. So clause coverage need not subsume predicate coverage. So here we saw in the first case, predicate coverage wasn't giving rise to covering every clause becoming true or false. So we introduced clause coverage. But in the presence of connectives like or, through an example here, we understand that clause coverage can be met while the predicate stays as true, right? So neither of these seem to be good enough. One doesn't exercise all the clauses, one doesn't exercise the whole predicate to be true ones and false ones. So is there a solution out? The solution is the following. So we say instead of doing predicate separately and clauses separately, consider all the combinations of true false values. So for each predicate, your test requirement contains the test requirements for all the clauses in that predicate to evaluate to each possible combination of true false values. Combinatorial coverage is commonly called as multiple condition coverage. What we mean by that is take every possible assignment of true false values and make the clauses true ones, false ones, all possible combinations, and test for the entire truth table. So I'm repeating the truth table for OR, which we have seen several times. Here, there are four different possible combinations because there are two clauses, two part two, four different combinations. That's what is listed in the four rows. So my test requirement says test it for all the four combinations. This is fine, seems doable for small predicates like this, but it's difficult to scale it up for larger predicates. Suppose a predicate had n clauses, let's say 3 clauses, 4 clauses, 5 clauses. If you consider all combinations coverage through the truth table, then you're practically considering 2 power n possible assignment of true false values to the individual clauses. Right, because one for each of the clauses, there are n clauses. Each clause can take true ones, false ones, totally 2 power n combinations. So this is an exponential number of combinations, and it's an expensive deal in testing to test for all the combinations of criteria. And like we saw in loop coverage, it may not be necessary to test all the combinations. First of all, the number of combinations can grow exponentially large with the number of clauses. If there are n clauses, then all combinations coverage needs 2 power n test cases to achieve its test requirement. And it may not be needed also. So what we need basically is a criteria that captures how each clause influences a predicate, and can we do it without spending an exponential number of test cases. That's what is the goal. So we consider this notion of a clause determining a predicate. What we mean by this is, let's take an example to understand what it is. We'll take the same predicate that we have looked till now in this lecture, A or B. Suppose the clause A was true right up front. Then, irrespective of whether B is true or false, the semantics of the OR connective says that the predicate will evaluate to true. So B, in some sense, has no influence on the truth or falsity of the predicate P when the clause A is true. On the other hand, suppose the clause A is false, okay, then we can say that the truth or falsity of B completely determines the truth or falsity of the predicate P. A is false, let it be. P is A or B. Suppose B also becomes false, then the predicate P will return false, will evaluate to false. Suppose B becomes true, then the predicate P will evaluate to true. Is it clear? So when A is false, we can say that the clause B completely determines P. If B is false or true, the truth or falsity of P also changes with the truth or falsity of the clause B. So this is what we mean by a clause determining a predicate. We would like to test each clause under the circumstances of a particular clause determining a predicate. Let's go ahead and formalize that. At any given point in time, let's say there is a predicate P, and let's say it has some number of clauses. I focus on one clause at a time in that predicate, and at any point in time, particular point in time, the clause that I focus on is called as the major clause. All other clauses in the predicate are called as minor clauses. So as I told you, we're just going to take turns. We're going to focus on each clause being a major clause in turn. Now let's formalize when this major clause that we are going to focus on determines the predicate P. So given a major clause Ci in the predicate P, we say that Ci, sorry, there's a typo here. Please read this as Ci. We say that Ci determines P if all the minor clauses, the other clauses, let's call them all as Cj, collection of Cj's such that j is not equal to I, have values such that changing the truth value of Ci changes the truth value of P. Is it clear? So we say, let's take a predicate P. Let's say it has certain number of clauses. You focus on one clause in that predicate. The clause that we're going to focus on is called the major clause. The rest of the clauses are called minor clause. We say that the major clause determines the predicate P if the minor clauses take true false values such that if I change the true or falsity of the major clause, then the truth or falsity of the predicate also changes along with that. Is this clear? This does not require that the major clause that we focus on is the same as that of P. It doesn't say that. Neither does it say that if the major clause is true, then the predicate will also become true. And if the major clause is false, the predicate will also become false. It doesn't say any of these things. It just says that the minor clauses take true false values such that if the major clause becomes true and changes to false, the truth or falsity of the predicate P will also flip or change. It could be the same as minor clause, as the major clause, or it could flip the truth or falsity of the major clause. We'll see a few more examples. So to start with, we call it as active clause coverage. So what do we mean by active clause coverage? We say for each predicate P, let's consider major clauses, let's say one at a time, Ci, and let the minor clauses be Cj, take values such that Ci determines P. Your active clause coverage says there are two test requirements. Ci evaluates to true and Ci evaluates to false. Let's look at the same example that we've been using till now in this lecture. P is equal to A or B. Let's say for now, look at where my mouse is moving. Ci is A. That is, we are focusing on the major clause is A and on A determining the value of P. In this table, this is not exactly the truth table. This is just some other table. The bold T and F indicate that A is becoming the major clause and A is becoming true ones and false ones. T for true, F for false. For A to determine P, in this example of P equal to A or B, if this should happen, if the truth or falsity of P should change with A becoming true ones and B becoming false ones, the minor clause B should stay false. That's what is given in the last column here. The next option is B becomes the major clause, that is Ci is B. So the bold values against the column for B, true and false, says that B is the major clause, and A, for B to determine P, A should stay false. So that is what is given here. FF for A is that A is false. So to summarize how to read this table, this predicate P equal to A or B has two clauses. Here A is the major clause. First case, A becomes true once, A becomes false once. For A to determine P, B stays false as a minor clause. In the second case, B becomes the major clause. For B, it will become true once, false once, and for it to determine P, A as the minor clause stays false. That's this table. If you see across these table, A takes true once, false once, and B takes true once, false. A stays true, false. B is false. A is also false. That repeats twice here, row 2 and row 4. So we consider it only once. And otherwise, between A and B, there's true ones and false ones. So in terms of the number of distinct test requirements, A is true, B is false. That's the first row. Second row is A is false, B is false. Fourth row is also A is false, B is false. That's given towards the end here. And the third row, A is false, B is true, is the other test requirement. I hope what is active clause coverage is clear to all of you. So what does active clause coverage do? If a predicate has n clauses, take each clause to become a major clause in turn. So your test requirement has requirements for each clause to be the major clause. So for a predicate with n clauses, n plus 1 distinct test requirements are enough because each clause takes turn to be a major clause. Like we saw here, this predicate had 2 clauses and totally we had 3 different test requirements. In general, we're not giving a proof of this result. In general, if I have a predicate with n clauses, n plus 1 distinct test requirements will be sufficient to achieve active clause coverage. So if you Google for popular terms in software testing, you are highly likely to encounter this term called modified condition decision coverage, abbreviated as MCDC. This is a popular criteria that several certification standards mandate for testing. What is called MCDC is what we call as active clause coverage. So decision is the whole predicate. Individual conditions in the decisions are the clauses. I modify conditions individually. That is, I consider each clause to be major clause individually, assign it true or false, that is the modification, such that the decision or the predicate is covered. That is, it becomes true or false once again. So MCDC that you find otherwise in the testing literature is what we call as active clause coverage. So now in active clause coverage, remember, we are saying that each clause is a major clause and that major clause has to determine the value of P. We don't talk about what are the values that the minor clauses take. The minor clauses, we just say, should be such that the major clause can determine P. But suppose we start putting conditions on what values the minor clauses can take, then we can get 3 variants of active clause coverage. One is called general active clause coverage, general ACC, GACC. The other is correlated active clause coverage. The third one is restricted active clause coverage. It's not too complex, so we'll see what the definitions are. First one, general active clause coverage, abbreviated as GACC. Active clause coverage, I hope by now you're comfortable about what it is. Take a major clause, let minor clauses be such that the major clause determines P. Your test requirement says evaluate the major clause to be true once, evaluate the major clause to be false once. The values chosen for minor clause in GACC says they need not be the same as when CI is true or when CI is false. So it basically means the word, focus on the word general. So we take this active clause coverage, that's the same, and we add an adjective general to it. We prefix the adjective general to it. The word general in English means it's general, no more conditions put. That's what is this part. It says the values chosen for minor clauses need not be the same. Basically, I don't put any conditions on it. I will leave it generally. So that is what is general active clause coverage. So this first part is the same as active clause coverage. For general active clause coverage, we say that the values chosen for minor clauses do not need to be the same as when CI is true as when CI is false. which means I put no conditions on the values taken for minor clause. This could be bad because if I put no conditions on the values taken by minor clause, I might even lose the fact that I want the major clause to determine the predicate. Here is an example. So because of that, it can happen that GACC does not even subsume predicate coverage. For example, suppose you consider a predicate that looks like this: A if and only if B. It's a valid logical predicate. It may or may not appear as a label for an if statement or any other decision statement, but it's a valid logical predicate. So now, for this particular predicate, it happens that clause A will determine the predicate P, that is, will make it true or false for any value of B because they are equivalent. Suppose we choose this test input: both A and B are true and both A and B are false. Then what happens in this case? Because the predicate P is A equivalent to B, I assign A and B true together, or I assign A and B false together. So P evaluates to true in both the cases. So predicate coverage is not achieved. So in general active clause coverage does not subsume predicate coverage. So I lose my very reason that I started out with about active clause coverage. So let's look at the second, this part, correlated active clause coverage. Again, focus only on the adjective that we add in the front, correlated. So the word correlated says minor clauses take values such that the major clause does determine P. So the first part is the same as for ACC. Take a predicate P, let's say fix a major clause CI in P, choose minor clauses CJ such that CI determines P. Your test requirement has two values for CI. CI evaluates to true and CI evaluates to false. Now, the values chosen for minor clauses for CJ must cause P to be true once for the value of major clause and must cause P to be false for the other. Is this clear? So that is what is correlated. So the minor clauses take values such that for sure they ensure that the major clause determines the predicate P. That is, the truth or falsity of the predicate P changes with the truth or falsity of the major clause. For example, if you take the same predicate that we saw in the previous slide, A equivalent to B, the correlated active clause coverage criteria tests are like this. Suppose A is the major clause. Test set would be, read this TT as assign A true, assign B true, and FTS assign A false, assign B false. And similarly, when B is the major clause, test set is assign B to be true once and false once. That's the second part in these two strings. And A stays as true, in which case B will sure flip the value of B. So if you see, like we saw earlier, TT is common here. So, but FT and TF are different. So we get three test requirements: A to be true, B to be true, A is true, B is false, A is false, and B is true. And by definition, correlated active clause coverage will subsume predicate coverage because it says that the minor clauses take values such that the major clause determines P. P's value, true or false, flips for the major clause. The next is restricted active clause coverage. For each predicate P in P, each major clause CI in P, choose minor clauses CJ such that CI determines P. This part is the same. The test requirements have two parts. CI becomes true, CI becomes false. The last sentence is what varies. So for this, again, we focus on the word restricted. It says restricted ACC. So by restricted, what we mean is that the minor clauses take values that are the same. That is, they are all true together, they are all false together, or a particular minor clause stays true, another minor clause stays false, but it's the same as when the major clause is true and as when the major clause is false. Is this clear? The minor clauses take values which is the same as when the major clause is true and as when the major clause is false. So before we look at the example, let me just go back and re-explain this because it's a slightly new thing that we are seeing. We first saw predicate coverage, then we saw clause coverage. We realized that they're not good enough. Then we said, okay, we'll consider all combinations of true false values. Then we said, oh, this is getting expensive. Then we said, can I have the notion of taking one clause at a time and letting that clause determine the predicate? So that is the major clause determining the predicate. That's what we call active clause coverage. There are three variants that we can think of based on the values that the minor clauses take. General, where there is no restriction on the values that the minor clauses take. So it can be so general that it need not subsume predicate coverage. Correlated, where the minor clauses put together ensure that they cover major clause determines the predicate. Restricted, which says the minor clauses all take the same values as when the major clause returns true and as when the major clause returns false. So we'll see a slightly larger example. Let's say the predicate that we want to consider is this: A and B or C. It helps to write the truth table for the predicate. What I have written here is the truth table for the predicate. All of you should get comfortable with reading truth tables like this. This predicate has three clauses, A, B, and C. So each of A, B, and C can be assigned true, false values. There are three clauses. Each one takes two possible values. So totally there are 2 cubed 8 different values, true, false values that exist for A, B, and C. Those are given in these 8 rows that are numbered 1 to 8. For example, in the first row, all the three clauses A, B, and C take the value true. In the second row, A and B take the value true, C becomes false. In the third row, A is true, B is false, C is true, and so on. In the last row, all three are false. This last column in the truth table is the final evaluation for the predicate. In the case when all the three clauses are true, which is the first row, the predicate evaluates to true. In the case where A and B are true, but C is false, the predicate again evaluates to true. But when A is true and B and C are both false, if you see B or C will return false, and this is an AND, this is row 4, the predicate will evaluate to false. And in rows 5, 6, 7, and 8, A happens to be false. So A and B or C, because of the presence of and A is false in rows 5, 6, 7, 8, the whole predicate will return false. Is that clear? So this is how we write the truth table, and we use the truth table to work with active clause coverage criteria. So let's first look at correlated active clause coverage. That's the most useful thing, because why? It ensures that the minor clauses take values such that the major clause determines the predicate P. That is, the truth or falsity of the major clause flips the truth or falsity of P. So in P is equal to A and B or C, for clause A to determine P, because it's an AND, B or C must be true. If this is true, then if A is true, then P will become true. If A is false, then P will become false. Now let's focus on B or C. B or C can be made true in three possible ways, right? Because it's an OR. Both are true. Both B and C are true. At least exactly one of B or C can be true. The other can be false. So I take this truth table and I look at rows where this is satisfied. So these are the rows. Correlated active clause coverage from the truth table based on these two observations can be met by these rows, right? In all the three cases, if you see rows 1, 2, and 3, B or C becomes true. B and C both are true in one. In row 2, B is true, C is false. In row 3, B is false, C is true. Right? In all the three cases, A is true. So this whole predicate will return true. Now A is the major clause. Rows 5, 6, and 7 ensure that A is false and B or C stays true. It's again the same combination for B or C as rows 1, 2, and 3. True, 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 false, false, true. All these cases, B or C as a sub formula will return true. Rows 1, 2, and 3 will make A true. rows 5, 6 and 7 will make A false. So one of this and one of this, one of rows 1, 2 and 3 and one of the rows 5, 6 and 7 as a test requirement will ensure that clause A as the major clause will take true ones, false ones, and because B or C will evaluate to true, A as the major clause will determine the predicate B. Is this clear? So this is what we mean by test requirement for correlated active clause coverage. Let's take the same clause and look at what the test requirement for restricted active clause coverage is. Again, for A being the major clause, you can similarly work out for other clauses. Suppose A is the major clause. What does restricted say? Minor clauses take exactly the same values as when the major clause is true and as when the major clause is false. So in this truth table, let's say A is the major clause. So A becomes true once, A becomes false once. So I could, let's say, choose any of the rows 1, 2, 3 and 4 for A being true, or any of the rows 5, 6, 7, 8 for A being false. But restricted active clause coverage says the minor clauses take the same value. So suppose I choose row 1 for A being true, then I have to choose row 5 for A being false for restricted ACC. Why? Because row 1 and row 5 make sure that A is true and A is false as the major clause, and minor clauses B and C take the same value in both the cases. Both are true. Similarly, I can pair row 2 with row 6. A is true once, false once. Minor clauses B and C, in both the cases, B takes true, C takes false. Similarly, I can pair row 3 with row 7 for the same reason. A true, A false. Minor clauses B and C take exactly the same value. That's what is written here for restricted active clause coverage. So we've picked rows from the original truth table. If you see here, A is true, false. Minor clause B and C take the same value. Predicate becomes true, false. We are lucky. Second case also A is true and false. Minor clauses take the same value. Predicate becomes true or false. Third case, A is true, A is false as the major clause. Minor clause takes the same value. Predicate becomes true or false. This is restricted active clause coverage. It so happens that it also subsumes predicate coverage because it makes the predicate true once, makes the predicate false once. Is this clear? So we haven't worked out general active clause coverage for this example because general active clause coverage, as I told you, places no conditions on the values of the minor clauses. So you could take any combination based on your major clause from this truth table. So I hope this example will help you understand what CACC and RACC is. We will give you a few exercises to work out how to get ACC criteria. And in the next lecture, maybe one lecture after this, I'll tell you how to let a clause determine a predicate. So I'll stop here for now. We will continue in the next lecture. Thank you.